Hey guys, Mr. Backberg here. In this video, we're going to look at solving quadratic equations by graphing. So we're going to be looking at quadratic equations that look something like y equals ax squared plus bx plus c. And what we're actually going to be doing is we're going to be taking our quadratic equation and setting it equal to 0. So we're going to have an equation that looks like 0 equals ax squared plus bx plus c. And we're going to go through and solve this equation to figure out what x values would make this equation equal 0. Now these solutions sometimes have different names. Okay, sometimes we just call them the solutions to the equation. Sometimes you might also hear these solutions referred to as the roots of the equation. If you're dealing with functions, then you might hear these solutions called the zeros of the function. But specifically in this video, we're looking at solving by graphing. So what we're actually going to be looking for are the x-intercepts of our graph. But just keep in mind that all of these different names are referring to the exact same thing. The x values that if we plugged them into our equation, it would make the equation equal 0. So I just said we're looking for the x-intercepts for the graph. And what that means is we're looking for where the graph crosses through the x-axis. And there's actually 3 different things that can happen when we're looking at the graph of a parabola. Our parabola could hit the x-axis in 2 places. So that would have 2 solutions, 2 x values that would make the equation equal 0. It's also possible to have a parabola that only hits the x-axis in 1 spot, so that equation would only have 1 solution. And the last thing that could happen is we might have a parabola that doesn't hit the x-axis at all, so it wouldn't have any x-intercepts, so that would mean that that equation would have no solutions. So in this first example, we've got the equation y equals x squared minus 2x minus 3. And what we want to do is we want to graph this out to look at the picture so that we can find the x-intercepts. Now I'm actually going to use a website to help me graph this out to get a picture of what this parabola would look like. And I'm going to use the website www.graphsketch.com. So if I go to that website, it's going to end up looking something like this. Now the first thing that I need to do is get my equation typed in. So down at the bottom left-hand corner, they use f of x. They're using function notation. But what we want to remember is that this f of x just means the same as y equals. So in this first equation, I want to type in that x squared minus 2x minus 3. Now when you're doing the x squared, we'll type in the x. To get the exponent, we want to use a caret key. And that's the little symbol that's above the 6 on your keyboard. So I'm going to hit Shift 6, and that puts the caret key in there. I want a squared power, so my exponent is 2. And then it's minus 2x minus 3. That's our first equation that we want to graph out. I'll hit Enter, and it gives me that picture. Now we want to remember that we're looking for the x-intercepts, or the places where your graph crosses through the x-axis. So I see 2 places here. I see a spot right here where my graph crosses through the x-axis, and I see another spot over here where this graph crosses through the x-axis. So the solutions, the answers, are the x values where your graph hits the x-axis. So if we look on the left-hand side of this parabola, that's 1 space to the left, so that's at the x value of -1. And if we look on the right-hand side of our parabola, that's 3 spaces to the right, so that's at the x value of 3. So the solutions for this equation, or the roots or the zeros, one of them we said was at x equals -1, and the other one was at x equals 3. So this one has 2 solutions because the graph hit the x-axis in 2 spots. Taking a look at this example, we've got the equation negative x squared plus 2x minus 1. So I'm going to bring up that website again. So I'm at graphsketch.com. The first thing I want to do is get that equation typed in. So negative x, and then I need to do my caret key for the squared, plus 2x minus 1. I hit Enter, and it'll give me that picture. I'm looking for the x-intercepts, the places where my graph hits the x-axis. I notice that this parabola only hits the x-axis in 1 spot. So this is a 1 solution case. That x-intercept is happening at the x value of 1. So for my solutions, or the zeros or the roots, it's at the x value of 1. Looking at our next example, we've got y equals x squared minus 4x plus 7. So I'm going to bring up that website again, graphsketch.com. In the first equation, I'm going to type in x, and then I need my caret key for the squared, minus 4x, and then plus 7. I hit enter, and it'll give me this picture. I'm looking for where my graph hits the x-axis, but as I look at the picture that I've got for this parabola, it never ever touches the x-axis. So this one is going to be a no solutions case. There are no x-intercepts, so this equation does not have any solutions, no roots, no zeros. So this one we said was no solution. Now, I'm not going to run through and type all of these in, but here's some extra examples of solving by graphing. So this first one, this one's written in function notation. So instead of saying y equals, this one just says f of x equals, but the process is still exactly the same. We would want to type in the x squared plus x plus 1, graph it out, and look for the x-intercepts. If you graph this one out, this one ends up being a no solutions case. Again, same thing with this one. I'm not going to graph it out, but you can in order to check your answers. So we've got x squared minus 6x plus 8 equals 0. So we would go to that website. We would type in the x squared minus 6x plus 8. We would graph it out. This one should have x-intercepts at 2 and also at 4 for the solutions. So this one has 2 answers there. For our next equation, there's actually a little bit of an issue with this one. All of our equations have said y equals or f of x equals. The last one said equals 0. This one has that x squared minus 5x equals 6. Before we can graph this out, we actually want to get our equation equal to 0. So we need to do a little bit of algebra first. So I want to take this 6 that's over on the right-hand side, and I want to move it over to the left-hand side. It's a positive 6, so to move it over to the other side, I'm going to have to subtract 6 from both sides. So this is going to give me the equation x squared minus 5x minus 6 equals 0. So now this equation is ready to type in to graph it out. So we would type in the x squared minus 5x minus 6. And again, we'd be looking for the x-intercepts where our graph hits the x-axis. This one should have 2 solutions. It should have an x-intercept at x equals negative 1. And it's also going to have an x-intercept at x equals 6. And then for our last example, kind of similar to the previous one, this equation right now does not equal 0. So I want to do a little bit of algebra with it first in order to get it to equal 0. So I'm looking at this minus 6x that's on the right-hand side, and I want to move that over to the left-hand side. It's a minus 6x, so to move it over to the other side, we're going to have to add 6x to both sides. So we would get negative x squared plus 6x minus 9 equals 0. And now I should be able to type in this left-hand side, this negative x squared plus 6x minus 9. I should be able to type that in and graph it out. Again, we're looking for the x-intercept, so where our graph hits the x-axis. This one is just a one solution case. We should see an x-intercept at x equals 3. That's going to be it for this video. Thanks for watching.